Welcome to Brain Vision.
Problem 764. We have a fish that is attached to a vertical spring and is slowly lowered to equilibrium position. So the spring initially was just this length here, but then a fish is attached to it and it stretches the spring distance d. So then we then say if this fish is attached to the end of the unstretched spring and allowed to fall from rest, what maximum distance will it stretch? So now that we know that the equilibrium position is at d, we basically push it back up to this position and we let it fall. How far does it go? And so we're going to use this hint here, calculate the force constant of the spring in terms of distance d and the mass m. So if we create a free body diagram for the fish right there at its point, we'll note that it has a force due to gravity on it, but what's holding it up is that we have a spring force, kx, and that's how far it's, where x is the distance has been stretched d. And so since those sum of forces is equal to 0 in that case, I'm writing faster than I speak, we have then that if we define this distance as positive, we have kx minus mg is equal to 0. So then you can solve and get k is equal to mg over x. But since x is the distance d here, we get mg over d. Okay, so now we have to write down our conservation energy formula for that release from rest here and see how far it falls. So we have potential energy is going to then release, and it's all going to come down to some bottom here. That's a fish, and that's going to have zero velocity there when it's at a stopping point, and then it will start to go back up. But at this point, we're going to assume that there is no potential energy, and that there's going to be only elastic potential energy. Okay, so we have that equal to those, and we have that equal to the potential energy elastic when it's completely stretched at position 2. So then we get mgx equal to 1/2 kx squared. And here I'm going to define this for this part of the problem, x positive from this point here. Okay, so what we can do then is cancel out one factor of x, and we get x to then be equal to 2mg over k. We can substitute in what we have for k. That's 2mg over mg over d. And that's going to be equal to mg d over mg. And so then we get 2d. That's going to be the distance that it falls to when it's stretched. So we can think about this to be that when we have the fish here in this position, when we lift it up, we add gravitational potential energy, and then it falls to that point below this equilibrium position at same distance.